Yay! I have the keys to unlock Pocket Ronnie. Okay, today we're going to be doing vectors. Vectors are shown by an arrow, and vectors have two components to them. The first component is magnitude, which tells you how long the vector is, and the second component is the direction. Like, look, if I have this like compass, north, south, west, east, I can draw a vector. A vector is shown by an arrow. You use the arrowhead to show which direction it's pointing. So this is a vector, and let's just say it represents somebody started at this point walking and they walked north this far. Well, let's just say that vector was 50 feet. The magnitude of that vector is 50 feet. That is the magnitude. The magnitude tells you how long the vector is, and the direction is what direction. For this specific vector, the magnitude is 50 feet north. So the direction is north. Vectors don't have to necessarily be north, south, west, or east. Like, let's say you have this x and y axis, and we have a vector that starts from the origin, and it goes. Let me draw a little bit better. Let's just say it does that, and let's say the magnitude is 30 feet. Means someone started here and they walked to this point, and they walked 30 feet, and their direction is this angle. We're going to say this angle is 60 degrees. When you're dealing with an x and y axis, then at x, that's 0 degrees. There are 360 degrees in a circle, so if on the x-axis this is 0 degrees, and then to go from here up to here, we went 90. Each quadrant is 90 degrees. So this would be 90, and then to go another 90 degrees, here I'm at 180, and then to go another 90, 270, and then another 90 is back around the circle at 360 degrees, which is also 0. Remember, there are 360 degrees in a circle. So if I was to start here and I rotated up to there, I went 60 degrees. So this vector is 30 feet, and the direction is 60 degrees. So this is the direction, this is the magnitude. Another thing to remind you of is, or to show you, let's just say, okay, I'm going to draw this on this XY axis. Let's say that someone started walking, they started right here at the origin, and then they walked east. Okay, that would be east. Okay, north. Okay, they started at the origin, they walked east, and then they turned and they walked north. I can add this vector going horizontal and this vector going vertical, and adding those two vectors together, when we add those two vectors together, that is the resultant vector. One thing about vectors is vectors are drawn head to tail. Here I stopped at this point, that's the head of the first one, and so I draw the tail of the second one there. So I went to the I went to the east, and then I turned and went north, and when I add these two vectors together, I get the resultant vector. This vector right here is called the resultant. And the resultant starts at the origin. It starts at the same place that the first vector starts at. My first vector started here. The resultant also starts there. Okay, what kind of triangle did we create here? We created a right triangle. Okay, we went some x direction, then we turned and went some y direction. And in a right triangle, what is this side called? That's always the hypotenuse. Okay, so when you have a right triangle, we can always use Pythagorean Theorem. So in our problems, we're going to know the distance that someone went in the x direction. Then they're going to turn, and we're going to know the distance that they go in the y direction. Well, if we know x and we know y, we can use Pythagorean Theorem to solve the hypotenuse. So remember Pythagorean Theorem, leg squared plus leg squared equals hypotenuse squared. Here in my case, I'll know the x direction. I will know the y direction, and then I can solve for the hypotenuse. So in this lesson, you're going to be using Pythagorean Theorem. You will also be using trigonometry functions. So, just as a reminder of trigonometry functions. So, let's take this xy axis. We're going to draw ourselves a right triangle on here. Let's say that here was my vector there, and it's made up of an x component and a y component. Someone walked east and then they turned and went north, and then here is my hypotenuse. Okay, right triangle. You can always use trig functions on right triangles. I'm going to call this angle theta. That would be the direction of the magnitude, whatever degrees that is, whether it's 45, 60, whatever. So remember, in trig functions, if theta is here, the hypotenuse is always across from the across from the right angle. So here's your hypotenuse. This is your x component, this is your y component. If you have a little man standing at theta, everything is relative depending on where you're standing. We're going to be standing at theta. Okay, that's a Greek letter theta. If you have a man standing at theta, then the y side would be called the opposite side. That is the side opposite of me. If I'm standing here, then the x component would be the side that is adjacent to me. Here are your three different trig functions. By definition, sine theta, sine is opposite over hypotenuse. Opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. So that stands for adjacent over hypotenuse. Tangent theta is opposite over adjacent. The opposite side over the adjacent side. We will be using trig functions in vectors. Also, with sine, cosine, and tangent, there is an acronym that can help you remember. So, TOA. Sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So this acronym, SOHCAHTOA, can help you remember the trig functions.